Good evening, everyone. Welcome to Physics Wala Vidyapeeth Hyderabad. So today we are starting our one-shot series for NEET 2025. So myself, Prashant, taking physics one-shot series. So today we are going to start our first topic, units and measurements. In this way, we'll be taking for the next 15 days. So we will be completing one by one the chapters. And after physics, you'll be having your chemistry and then your bio and consisting of either botany or zoology. That is the plan for the rest of the days until April 28. Okay, so why do we need to study this particular chapter? And the now as the days are coming very near, you need to revise your concepts as well as especially the PYQs. So we'll be looking for that reason. The reason for this series is just to make you revise through questions the concepts. Majorly we'll be doing the important model questions for topic wise. Like if you see this chapter, units and measurements, the three important topics are dimension analysis, error analysis, and the instruments. So we will see the first the trend, how the questions have been asked in this particular chapter across the years 24 to 25, the last 10 years. Here if you see, every year they are consistently asking 2 to 3 questions. So easily you can expect 2 questions from this topic either, and the important topic of this chapter will be the dimensions. You can see the questions only on dimensions out of, like if you see 12, 14, 19, out of 19 questions, 11 have come from dimensions. So dimensions such a important topic. And other questions which have been asked are also very easy topics here. Okay, so let us dive into the topic. What are the questions which have been asked? Again, we are going to deal with concepts while dealing with PYQs. So PYQs are targets, so basically they cover all the important models. Okay, so starting the first question here, very simple questions. That is, so you see the plane angle and solid angle have what? What is the thing which is common? They have the units, but they don't have dimensions. So very easy question. So direct. So in units related, there are only two things. What are the units are, and then the things are dimensions. What you have to know. And along with that, one more topic here we can see is between conversion of units. So conversion of units also the questions have been asked. So what are units is the first thing you have to just recollect, and how the units needs to be converted from MKs to CGS and from one system of units to another system of units. We'll see the next question where you see the question which is based on conversion of unit. So they gave the question regarding some energy related. Energy required to break one bond of DNA is 10 power minus 20 joules, which is a SI unit. But now they're asking convert into EV. So in conversion, what do we know? 1 joule, you can say 1 EV first of all. What is 1 EV is equal to 1.6 into 10 power minus 19 joule. But now we want to talk about what is 10 power minus 20 joules. So if you see, so 1 by 1.6 into 10 power minus 19 EV is equal to 1 joule. Now if you multiply into 10 power minus 20 into 10 power minus 20. So now what will be getting? So if you see, so if this 10 power minus 1 divided by 1.6 EV is equal to 10 power minus 20 joules it is. Now which is the answer that we can pick from here? So 0.1 and 0 into 0.6. So 0.1 into 0.6 will be coming out to be 0.06. That is what, again, simple unit conversion. And what is the concept here? Unit conversion. That is whenever every measurement, again the simple concept, I will revise it for you. Every measurement that we take will have two quantities, right? One is the numerical value along with the unit. So for any measurement, n and u common, and n and u should be always a constant. So what you do? N1 u1 is equal to n to u2. And this unit conversion is one of the concept where even we can use dimension analysis for the unit conversion. Okay, so this is what the simple, we are starting with the very basics, and we'll go for the next the most important topic of the chapter, that is the dimensions and dimension analysis. First of all, just having a quick idea what the dimensions are. So dimensions are the powers, these are the powers to which the fundamental quantities are to be raised. Whenever you want to have a derived quantity, so derived quantity, they come from fundamental quantities. So to what powers these fundamental quantities are to be raised, so those powers are the dimensions of the fundamental quantities. Okay, so so what are the important quantities that we should remember? It is must. So if you remember, and again, it's not like you should remember all the list. I'll also tell you for some of the quantities how do we get it in very quick manner. Force, we must remember what the dimensions are: ml t power minus 2, mass into acceleration. And energy, work, torque, they have same dimensions. What dimensions are? ml square t power minus 2 it is. And charge, again, very simple quantity. So charge, even though there is a there might be some misconcept that it might be fundamental quantity, but it is not, based on current. So current is equal to charge by time. So charge is equal to, yes, current into time. Okay, so whenever we write dimensions, we put in a square brackets. Now if there is something, the things are which are not in your fingertips, like electric field, yes, we know. But if you want to get the dimensions of electric field, how to get in a quick manner? So then we have to recollect the formula. That is, what is electric field? Is force by charge. So force dimensions, charge dimensions, you put it and you'll get the answer. So what will be coming out here? M L t power minus 3 into ampere inverse. And sometimes we can also write I also. We can also go with ampere A. So in this way, so whenever if you want to find any new quantity dimensions, what you do? Recollect the formula. So for every chapter, you must remember the formulas. Without formulas, without revision of formulas, then we'll not be having that edge. Okay, that is what we will be doing across all the series: formulas, basic concepts, quick revision, and questions. Okay, you can follow the series across the days. So 1 hour we'll be trying to cover. So for whole physics, hardly we'll be spending 15 hours. So it is going to be benefiting you a lot, which will help you to reach that 120, 130 at least. If you're already there, if you're already scoring 150, this will give you that extra 10, 20 marks also. So do follow and do share for your friends as well. And if you want to find magnetic field, so again, formula. What is the simple formula that we can remember for magnetic field? So in terms of magnetic field, you do infinite wire mu naught I by 2 pi r. But again, we should know dimensions of mu naught, right? So or else think in another way. Magnetic force, right? What is the magnetic force due to magnetic force on current wire? So it is Bill. Easy formula, Bill. So from that, B is equal to, we can write what? F by I into length. So again, very easy it has become. So force dimensions we have ml, and one more length will come. So length gets cancelled, so L is gone. And then, so we have L power 0 we can write, and t power minus 2 along with that A inverse. That's how formula will help you. And if a gravitation constant, again, it is very, very common thing. So we have to use Newton's law of gravitation. And angular momentum, we can use MVR. And one more thing that I am pointing out here is Planck's constant. How Planck's constant, how angular momentum, how come they have same dimensions? Again, you can simply use Bohr's angular, that is quantization of Bohr. That is, what is that? We have MVR is equal to NH by 2 pi, right? See, that is a connecting point. Angular momentum and H have same dimensions. In this way, first thing is we should know dimensions. Then we can go for dimensional analysis. And before that, I want to just show you, like, direct questions have been asked on this. Like, which quantities have the same dimensions? Like angle, strain, then trigonometry functions. They are dimensionless quantities. Okay. And work, energy, torque, and they have dimensions same, that is ml square t power minus 2. And time, and these are time constants. Time and time constant, RC circuit, LR circuits, and root of LC, so they have same dimensions of time. Just giving you a quick review here, nothing else. So they'll give the option which of the following is odd one out, then they will give 4 options. So these are having same dimensions. Okay, so that's how we identify. And frequency, it is a time inverse, they are having omega r by L, inverse of these things. Okay, so just if you want you can take a screenshot of this. Okay, and then what are the quantities? We are still in the table where we are looking for common dimensions. Pressure dimensions, force by area, stress, force by area, modulus of elasticity, same, energy density, these all have the same dimensions. Energy density, it is energy by volume, but so energy dimensions has force into displacement and volume has area into displacement. So the displacement cancel. So same dimensions. That's why. So again, the formulas like half epsilon naught E square, half B naught B square by mu naught, they have the same formula. Now angular momentum, Planck's constant, just now we have seen that we have the same dimensions. Linear momentum, linear impulse have same dimensions, and velocity we can write in different format, root of gm by r, and e by b, velocity selector, have the same dimensions. So just this is what the idea that you are having for dimensions. So just they will might giving the questions, just we'll see that. Okay, what are the quantities that we are having here? So the questions based on dimensions, what we can do is f is equal to at square plus bt, it is given. Now we have to just find dimensionless quantity here. Okay, so what are dimensionless quantities out of this? So this is the question completely based on what is the concept. Every time we are reading a question, just have the clarity, the principle of homogeneity. The concept here is principle of homogeneity. Just we'll have a quick idea and we'll go for solving. What does it say? In an equation, all the terms should have same dimensions. So in an equation, this is force, at square and bt, all of them should have same dimensions. That means, so f dimensions are equal to alpha t square. And so what is dimensions of alpha? So force ml t power minus 2 by t square. So it becomes ml t power minus 4. Similarly, beta t dimensions is equal to force dimensions. So what is beta dimensions are? So ml t power minus, if it t comes this side directly, I'm writing minus 3. Now what do you want to find? We want the factor which is dimensionless. So if you want to have dimensionless quantity, we have to see the options now. There is no other choice. We have dimensions of alpha, we have dimensions of beta. Now we have to find the quantity. So basically we don't want m and l. If we don't want m and l, then we are left with no choice to divide alpha and beta. If we divide, let's see that are in the see the options. Okay, fine. Then ml t power minus 4 and ml t power minus 3. ml got cancel. So what is left? So t power minus 1. So alpha by beta. Now if you send this one, alpha t by beta, alpha t by beta has what dimensions? 0. Alpha t by beta has no dimensions. So that's it. So this is how, this is a basic model question where a little bit of mixed concept we can say. Nothing much is there and simple questions for solving. In this way we'll do more models. Just we are just started dimensions. We'll see. Again, so just now, okay, this was a question I was expecting. Again, see that the physical quantity which has same dimension formula as pressure. Just now we saw which quantities have the same pressure, stress, modulus of velocity, energy density have same dimension. So direct question. So what you can say? So modulus of velocity will be the answer. Direct, nothing much. In a 45 questions, at least you will find direct questions of 10. So easily you can score 40 across the chapters. We'll do basic revision of those things as well. Okay, so now we have again similar model question where they gave some equation where V is potential energy they are taking. Okay, let it be energy. And again I told you force and energy dimensions you must remember. Force dimensions are what? Again I am reminding you, ml t power minus 2. Energy dimensions are what? Ml square t power minus 2. You must remember. There is no other way. Okay. Now we are talking potential energy. Is there any difference? Kinetic energy, potential energy, spring potential, doesn't matter. Everything, every energy has same dimension. In formula they might be different, but dimensions are same. So we have dimensions of V, that is ml t power minus 2, right? And principle of homogeneity always should be in your mind. Then we have something called ax square. Okay, what is x? X is just displacement along x direction. So in terms of dimensions, can we write a l square? Okay, I'm writing. And root x they are saying. That means root l we should say. But dimensions of b, when you're adding root x plus b, when we can add something? We can only add something if we have same dimensions. So x, root x dimensions and b dimensions are same. So directly, since we are dealing with only dimensions, so directly we can write skip b. Okay, there. But finally, so first let us write dimensions of a. What is it coming? If you send first, this becomes m l 1 plus 1 by 2, 3 by 2, 3 by 2 minus 1. So minus 1 by 2 it became, and t power minus 2, this is dimension. But we want a square. Okay, fine, a square. So it will be m square L power minus 1 t power minus 4. Then saying divide by b. Okay, let us divide by b. What is b dimensions are? L power 1 by 2. So what is the answer? M square L power minus 3 by 2 t power minus 4. So just you have to look for that. And so okay, so what will be coming out here? ml square. Okay, m square t power minus 1 by 2. So we'll be having, yes, m square t power minus 4. This is what we'll be having. Okay, so that is what will be coming out. And next, again the question based on energy and gravitational constant. So what do you have? E, energy, we should remember. G, we should remember dimensions of E and G. So E dimensions are what? ml square t power minus 2. And how to find? Again, if you forget, if you forget dimensions of G, how to get dimensions of G? So G, where do we get it? Again, force. Okay, easy way. We have an easy way. Energy, potential energy if you take. What is the potential energy? Minus G m1 m2 by R. So we want energy by, okay, let me write U by G. What is U by G is there? This is m1 in terms of magnitude. m1 m2 by R. That is what? M square by L. So m square by L, m square by L. So this is what we'll be getting. Again, so this is how the questions will be asked in the dimensions. Okay, so again different cases. So what you have to do next is, again there is a mechanical quantity which has a dimensions of reciprocal to mass. So angular momentum, we have again m v r if you take it. Okay, m L t power minus 1. Okay, this is capital M, we should write dimensions. M L t power minus 1 and one more L. So this is not thermal conductivity. Again, thermal conductivity, we have to remember the formula. What is that? H is equal to Ka delta T by L. So again, there is no mass here, or even in energy is there. So then it is not going to be the answer for our. Again, torque is not the answer. So again, where do we find it? We'll get in the gravitation constant. M power minus 1 will be there. Direct questions. These are the questions which are asked, and these have been the questions which I've been asking for the last few years. Okay. So again, in this way, so force, energy dimension they are saying by using force, acceleration, and time. So basically, what is energy? If you take energy dimensions, same as work dimensions, and if you remember work, what is work is equal to force into displacement, isn't it? And if you're writing force into displacement, now how to write a displacement in terms of acceleration? Huh? So again, if half a t square, can you write it? Just an example. So we can write F into acceleration. They are saying it as capital A, and T is t square. FAT square. FAT square will be coming. Okay. So this is what we'll be getting. Okay. So now, which are the quantities? Same dimensions of solid angle. Solid angle is what? It is a unitless. It is dimensionless quantity. It has some units. So you have dimensionless quantity. So strain and angle, so they don't have any dimensions at all. Again, simple questions. Let us see one last question and then we'll go for next topic. Okay, so dimensions. Again, so here you see common terms, common things. Planck's constant. These are very commonly they asked. Planck's constant is there. Speed of light is there. Newton's gravitational constant is there. Now this is one of the standard model question it is. So usually asked standard model question. So in this standard model question, what is the method? What is the method of solving? So we have, they'll ask something to write. Yes, they are saying we should write length in terms of h, c, g. We have to write length. We have to write length in terms of h, c, g. So h power x, c power y, and g power z. Okay, so h power x. So what is the dimensions of h? Again, if you are just recollecting, h has same dimensions of angular momentum. So what is the angular momentum dimensions are? So we can write dimensions of h we are looking. So m v r, that is a m l square t power minus 1 it is. Okay, that is what the dimensions of h. And what is dimensions of c? So its speed, L t power minus 1. And dimensions of G, just now we saw. Dimensions of G, what you have calculated? Okay, or else just we'll find it once again. So how you can find it? Dimensions of G. So we can use the force. F is equal to G m1 m2 by r square ml t power minus 2 into L square by m square is equal to G dimensions. What will be coming out? Again, take your time. These are the questions. It will take some time, 2 to 3 minutes. And you have to do these kind of questions when? In the second round. Okay. So there are some easy questions. There are some lengthy questions, but not any difficult question. M power minus 1 L, L cube it is, right? And then t power minus 2. Okay, this is what the dimensions of G. So we have to use these three dimensions and we have to find the powers. L is proportional to, or we can write dimensions of L is equal to h dimensions ml square t power minus 1 whole power x, c dimensions L t power minus 1 whole power y. Again, I'll be erasing these things. M L cube t power minus 2 whole power z. Okay, so this is, we are not required with this. Now we have to solve this. What is powers of m is coming? M power x minus z. This is power of m. L dimensions are, okay, so just you add powers, then 3z, then powers of t power minus x minus y minus 2z. And then, so we have to equate to what? M power 0, L power 1, t power 0. Okay, now we have to solve the equations. X minus z, x minus z is equal to 0, 2x plus y plus 3z is equal to 1, minus x minus y minus 2z is equal to 0. Now we have to solve these three equations, and what we can do, in the place of x we can write z. So that is how we can easily eliminate. Okay, so in the place of z I can write x also, that's fine. Then what it becomes? 2x plus y, 3x is equal to 1. Then minus x minus y minus 2x is equal to 0. So from this what is coming out? 3x minus 3x minus y is equal to 0. This is one equation. Now next is solving. If you're starting to solve here, 2x plus y, okay, it becomes 5x plus y is equal to 1, minus 3x minus y is equal to 0. So if you add, what it is coming out? 2x is equal to 1, x is equal to 1 by 2, z is equal to 1 by 2, y is equal to what? Minus 3x it is coming, that is minus 3 by 2. So y is equal to minus 3 by 2. So that's it, we have the powers. So what should write? So finally, what it is coming out? L is proportional to h power x, that is h power 1 by 2, and c power y, that is c power minus 3 by 2, and g power 1 by 2. So basically h and g should be multiplied and should be kept a root, and c power minus 3 by 2. So we are looking at option 1, it is root hg by 3 c power 3 by 2 it is coming out. So this is, again, it will take some time. There are some questions, there is no other shortcut here. There's nothing to remember. The only thing is we have to solve this, and it will take 2-3 minutes, but this is a standard model question. There is nothing else they'll be asking beyond this. Okay, so make sure you are covered with these kind of models and it will be easy. And next topic now we are entering. So we're done with the dimension analysis, and there are small topics in between, like significant figures, rounding off, and these are the rules that we have to follow, and direct questions have been asked. Very simple questions. And we know how to count significant figures, right? What do you say? The simple rules are, it's all about non-zeros. Non-zeros are always significant. And if you see 4, 3, 2, all are significant. And what about zeros? So that's where the confusion might be. But simple, the zeros which are in between non-zeros, the zero between non-zeros, they are significant. Like if you see 1 and 5, these are in between non-zeros, so they become significant. And now the question is, what about others? The zeros which are coming after, the zeros which are coming before, they are not significant. The zeros which are coming after non-zeros, they are not significant. And in case of decimals, like 0.00325 is there. So the zero which comes after non-zero and after a decimal, they will become significant. But you see, these are coming after decimal but there is no non-zero before. So that's why these are not significant. So only 3 significant figures are there. That's it. And so if you see this 0 in this example, 1.4750, this is a 0 which is coming after decimal and after non-zero. So that is the only key here. A 0 which comes after decimal, and that is a big and here, and non-zero, then it is significant. Just you remember this, then you are good to go with significant figures. And then comes two rules. What are the two rules? While addition and multiplication we have to do addition subtraction will put together as one category, and multiplication and division will put as a one category. Okay, so in the case of addition and subtraction, so we are adding some numbers and finally we get the result. So should we accept the result directly? No. So in that case, in addition subtraction, the final result should have the minimum decimal places. Okay, so final whenever we are doing addition and subtraction, finally the result should have minimum decimal places. That we have to take care. We'll do. The questions have been asked, we'll do that. And whereas when you're doing multiplication and division, the final result, it should have minimum significant figures. How come we have to, how to remember this? Okay, what if we confuse? Okay, so that's the just we can make some shortcuts. That's what. So for multiplication and division, we should look for significance. You can make a shortcut as MSD. Again, we know MSD, the figure. So MSD, that is how I remember as well. So for multiplication division, S comes important. That is significant figures becomes significant. Okay, so for multiplication division, we have to look for significant figures. The questions again direct have been asked. So based on taking account of significant figures, just to do this subtraction. For subtraction, what it look for? Finally, it should have minimum decimal places. Right? We should take care of decimal places. It is right. So if you're taking care of decimal places, you see here 2 decimal places are there, and you see here what 4 decimal places are there. So finally answer should have what? Only 2. So you can directly here 2 is there. So this is wrong, this is wrong, this is wrong. So only one answer is there. Nothing to do only. Isn't it? If you have that idea, then nothing to solve only. Just based on one single rule, question, 4 marks. Okay, 30 seconds is required. That's it. No need to do also. Now they're asking to find area of rectangular field. How do you find area of rectangle? Length into breadth. So here they are talking about what? Again, they will give the hint using significant figures. Okay, considering. So for multiplication and division, what? For multiplication and division, what becomes important? Yes, significant figures become important. So here how many significant figures are there? 3. Here how many are there? Only 2. So finally answer should have how many? So 2 significant figures only. So here 1, 2, 3, wrong. Here 1, 2, 3, 4, wrong. Here 1, 2, 3, 4, 5. So simply wrong. Then only one answer is there. See how the questions directly they ask. So just based on one single rule, they are asking the questions like this. Again, 30 seconds, you can solve these things. Okay. So this is how. Again, one more question let us do on significant figures, then we'll go for error analysis. Okay. I hope you are all following. Again, very simple. This topic is directly you should be scoring 2 questions, 8 marks. 3 questions, 12 marks. There should be no doubt in this chapter. Even if 1 year calibers and screw gauge also, if you're having any doubt, we will revise it. Okay. So don't. Now, what do you think we are doing? So we are looking to find diameter of a spherical bob, and so 1 year calibers is given by using 1 year caliper, but it's nothing related to 1 year calibers. Okay. So what you're having here is, so we have certain measurements are given. So 3.33, 3.32, something like this, and then okay, and we have to find the mean diameter for this. How to find mean diameter? So mean diameter is equal to what? Just add them. So if you're adding 3.33 plus 3.32 plus 3.34 plus Again 3.33 plus 3.32. Then divide by total 5 measurements. Okay. Then we are doing division. In division, what you have to follow? Right? Significant figures. Here 3, here 3, here 3 are there. So here answer should be what? Uh, Everywhere 3. So answer should be also be having 3 significant figures. So if you are adding this, what will be coming out? Okay, just solving. So 3 point. So okay, 3 3. It becomes 6 5, 6 5. Okay, there is no other way. Just we have to do by normal addition. Okay, so 5, 9, 12, 12, 14, 1, 15, 16, 1, 15, 16. Okay, so this is 16.64 by 5. Now 5, again 3, then what will be coming out? Again 3, okay, 1, then again 1, 4. So it will be 2 and 4, 8. Okay, right. So we got the answer 3.328. But finally we should have what? We should follow the rules of significant figures. We should have only 3 significant figures. That means we have to round off. So again, rounding off, how do you do? The digit that we are rounding off, if it is greater than 5, then its preceding number should be increased by 1. If you're rounding off this, so what is the answer should be coming out? 3.33. So what is the answer should be coming out? 3.33 will be coming out. Again, that's direct question based on significant figures and rounding off. That's it. Okay. So we're done with the 2 topics here. One is measurable dimension analysis and then small topic of significant figures. Now we are entering into the next important topic, that is error analysis. Errors. Again, errors could be of multiple reasons. It could be personal error. It could be systematic errors. It could be random errors, right? And systematic errors, how do we improvise that? So we should make sure that our method is correct, and we should if the instrument is itself is default, then you should replace the instrument. And finally, if the personal error, if it is there, then we have to be paying more attention while taking the measurements. But how to eliminate random errors? You have to repeat the experiment multiple times. By repeating the experiment multiple times, a random error will be reduced. Okay. So, and how do we measure the errors? Errors are inevitable. Okay. We cannot conduct the experiment without having the errors. Okay. So whenever we take the experiment, so how do we measure the errors? That is one, some concept is there. That is different types of errors. How to measure? Absolute error, then mean absolute error. How do you measure? Then relative error, how do you measure? And finally, percentage error, how do you measure? Okay, absolute error, how to measure? Whenever you have, so we should find a mean value or the true value, then you subtract the measured value. So then in that way, what are the thing you'll get? You'll get the absolute error. And all the errors, if you calculate in this manner for all the measurements, then you should find the mean value of all the errors. So while finding the mean value, you have to take mod. Error should never be subtracted. Error should always be added. So in this way, if you take the mean value, then finally how to get relative error? That is a mean absolute error divided by mean value. And how do you find percentage error? It is a relative error into 100. Okay, this is how we calculate errors. If one measurement is there, in these many ways we can calculate errors. But if there is one measurement, if there is another measurement, and if you are adding or subtracting these 2 measurements to get another, so how do you get the error in X? How to get error in X? So if it is addition, if it is multiplication, if it is division, and if there are powers are there, so what you have to do? We have to follow these rules. Or this actually they come from rules of differentiation. By keeping in mind that error should never be subtracted. If you just keep in mind, then that is done. Like normally, if like X only, okay, X is equal to A and B are there. If error is there in A, if there is error in B, then what is error in X? We say add them. Error should always be added. Even if there is a minus is there, but still we add. That is what is the first for during summation. Next, multiplication. If X is equal to A into B, then by following the rules of differentiation, we get it. So what is this? X is equal to, so AB, so A into B, it's like what will happen? It is delta A by A plus delta B by B will be coming. Even that is same for division also. Okay. again. And if powers are there, what do you do with the powers? They become coefficients. Here a power n by b power m is there, so power becomes coefficient. And here even though it is in denominator, the power is negative, but error should be always be added. Okay, if you are not able to see, just here. So here n became coefficient, and delta a by a plus will come, m delta b by b will be coming out. Okay, so error should always be added. Okay, so by using these rules, we'll do the questions now first. Okay, so and okay, what is the first theoretical question that we're having is, in a while doing some measurements, errors coming due to unpredictable fluctuations in temperature and voltage supply. If the things are unpredictable, if the things are not in our hands, what they are random. Okay, how to eliminate the random errors? By repeating. And person errors is due to the individual, and least count error is due to the instrument, the smallest value it can measure due to that. And instrument errors is like zero error kind of things are. Okay, so but the question is to say which is this error. Okay, right. Now again, this is also a standard model question. It is very simple standard model question. Okay, how do we do this? We have different quantities, a given, b given, c given. They have errors, in it. Then if you are measuring x by using a b c d, what is the possible error in x? So how do you write? Just now we have seen, whenever the powers are there, powers become, yes, powers become coefficient. So power of a is given 2, so 2. Okay, we are writing delta x by x into 100. Okay, just I'll write delta x into 100. Okay, so then what should write? So first I'll write the things and I'll put 100 here. Just so power of a 2 delta a by a, then power of b 1 by 2 plus delta b by b. That's it. Power of c 1 by 3 delta c by c. Power of d 3 d by d. Now into 100, if you do, all these percentages are given. So delta a by a into 100, it's what? 1%. And delta b by b is what? 2%. Delta c by c is what? 3%. And finally 3 into 4%. We have to add them all. So 2 1 3 3 1 4 4 and 12. So what is answer here? 16% error. Very simple question. If you know, again, very basics here, nothing much is there to do. Okay, now this is also one more. In errors, they will give the error value, but in different manners. Again, we have taken here all the different model questions on errors. We'll solve them. Okay, right. Here we have, in an electrical circuit, we have voltage, and voltage and current is measured, and we have to find the value of resistance. How do you find the value of resistance here? Normally V is equal to what? IR. So what is R is equal to? V by I. So what is delta R by R is equal to? Again, following the rules, delta V by V plus delta I by I it is. And then do we have error in V? Yes, it is given 4, and the original value is 200. And error in current is 0.2, current is 20. Then what is the value of resistance? They are not just asking value of resistance. We have to mention with the value, you should also mention the error that is possible. So delta R by R, first let us complete this part. And okay, if you want, meanwhile, we can also calculate what is R value here. R is equal to V by I, that is 200 by 20, right? So R is coming 2. So if we take it and put it here, delta R by 2, so it is 4 by, sorry. Okay, so here what happened? This is 10 ohm it is. Okay, so delta R by 10 is equal to, so 4 by 200. If we send this 0 here, 200, so delta R 10, if we cancel out, it is what? 6 by 20. So it becomes what? 3 by 10. That is what? 0.3 ohm is error. So what is the error in the resistance is 10 is a value. Error possible is 0.3. So what is the resistance can vary between 10 plus or minus 0.3 it is. Okay, this is how. Again, this is a standard model question. Again, simple model question. Sometimes they may not give the error values also. Then how do we take the error if they don't give? That is I think you might know. That is, we have to use a least count error. And this is also a similar question where they give mass, radius, length for a wire and asking to find density. How to find density? Mass by volume. And here wire, volume, what you can write? Pi r square L. So they are asking percentage error. So delta rho by rho into 100 is equal to what? Delta m by m. Error in pi, no error, right? It's a fixed value. And delta L by L. Power becomes coefficient. Now just we have to substitute into 100. Yes, into 100 we have to do. So now nothing much to do. Just put the values. Delta M, error in mass 0.00. That is where you have to be careful. Simple. You'll say that you know the concept, but you did silly mistakes. So where you do silly mistakes, here only. So maybe taking 0, maybe different values you might be taking. That is where you have to avoid. You have to put more focus when the questions are easy, because they are scoring. So and then next 2 times of delta r error is 0.001. Here you can forget about units because both are in same units. So directly you can take 0.3. Then error in length, so 0.02 by 5 into 100. So okay, let us take it in the next step. Where does 100 will go? Okay, so if I take 1 0 here, I should shift this 1 0 here. And next, if you multiply with 100, it becomes 2. So it becomes 2 by 4, right? That's simple. Again, if I take this 0 here, this 0 here comes here. Next, if you multiply, it becomes 1. So it becomes 2 by 3. And directly, if you multiply 100, it becomes 2 by 5. Okay. Now, just approximate 0.5 percentage plus 0.66 percentage plus 0.4 percentage. All are percentages. So 1.56 percentage, 1.6 is the approximate answer here. Okay. Again, isn't it simple question? Again, these all are questions have been asked in the recent years only. Nothing else I'm picking here. Again, here also it's a direct question. Okay. So right. Next we can go for. Okay. So if we have, since we have, okay, next we'll do this one question and we'll go for instruments. Okay. So what is the thing which are given here? G. They're asking to find percentage error in G, and they give as a hint the formula also given, G from the time period of simple pendulum, and we want to find percentage error. What is the percentage error? Delta G by G into 100 is equal to delta L by L. The power is -2, but we should take 2 by T. Just if we substitute, then the error in L is 0.1 by 10 plus 2 into delta T is 1 by 100. Okay, so these all are least count errors they are. So I hope we'll discuss the least count also. Just I'm giving you what is least count error. Like for example, you are using a scale, and if you are using a 1-year calipers, so you got a measurement of 10.56 centimeters. So for this, what is the least count error? So the last digit is always doubtful for us. So the least count error is just you take the last digit as 1 and put everything 0. So what is it? This is the least count error. So sometimes if they don't give the error, you should take least count error. That was I was talking about it earlier. Okay. So this is one thing just you keep in mind, not related here, just as a concept I'm telling you. Now, how do we calculate into 100? We have to do what? Into 100 we have to do. So when you do into 100, what is the percentage it is coming out? So again, becomes 1 plus 2. So what is the percentage error? 3% it is coming. Okay, right? So lastly, we are coming to the instruments, the two instruments. Questions again have been asked, but not as frequent as dimensions. But if they're asking 3 questions, for example, so they again they one will be from dimension analysis, one may be from error analysis, and one may be from instruments. Or instruments are dimension analysis. That is one thing which will be common. Okay, so what is the thing we are having here? So we have a screw gauge. What is the principle behind the screw gauge is? So we have this U-shaped thing to hold the object, or maybe we can put some spheres here, and we'll have our circular scale. When we have our circular scale, and as we turn, as we rotate here, what will happen? The screw will be moving, and then we'll be starting to take the measurements. We'll have our main scale here, and we'll have our circular scale readings. So for any scale, what is the first important thing is, what is the least count? What is the least count for the scale? We should know. Then only we can proceed to find the measurement or reading, whatever it is. So for the finding the least count, the principle is, for every one turn of a circular scale, so the screw will move by particular length, which we call it as a pitch. So least count, how do we calculate? It is a pitch of the screw divided by number of circular scale divisions it is. Okay, and what is the pitch means? It is a distance moved by the screw, the circular scale, and based on number of rotations. If only one rotation is there, then what are the distance it has moved is a pitch of the screw. And then how do you take the finally the reading? So we should take the main scale reading, and we should take the least count, and we should take the circular scale reading. How do we do that? Very simple. So wherever the screw begins, the value that you are seeing in front, the value that you see in front of the screw or the circular scale is a main scale reading. I'll just give you an idea. So if this is a scale, and if this is 0, and the readings are there like this, 1, 2, and if you are seeing fourth unit, that means what is the main scale reading is 2.4. That's it, 2.4 centimeters. That's it. And least count, you know how to calculate. Pitch of the screw divided by the number of circular scale divisions they will be giving. And then circular scale reading, how do we take it? Again, it is also simple. So you see this line, the headline or the main scale line. So whichever it coincides with, on this divisions will be there. Like for example, 45, 46, 47, 48, 49. If this line is coinciding with 49, then you should take 49th division here. That's it. Okay, we have seen how to take main scale reading. We have seen how to calculate least count. Then you put them together, and then you will be getting the overall reading. Okay, and maybe error is possible if nothing is kept in between. If 0 matches with 0, then there is no 0 error. If 0 lies right side, then there is a positive error. You should calculate in the same manner. You calculate positive error, then you subtract. Okay, you'll get the, finally when you subtract, you will get the correct reading. Okay, we'll see the question on that as well. Okay, so let us see the basic. A screw gauge is given, its least count is already given. Okay, the least count is already given as what? Some 0.01 millimeter it is. And number of divisions are also given. Number of divisions on circular scale is some 50. Now they're asking pitch. Again, see, you might think very easy, right? That's how the questions are there. Easy questions also there. So normally what is least count is equal to pitch by number of divisions. Now they're asking pitch. What is pitch is equal to? Just multiply 0.01 mm into 50. So how much it will be coming? So 101, 0.5. So it will be what? 0.5 mm it is. Very simple. Again, these all are PYQs only. You learn the basics. For NEET, you learn the basics. You apply the basics properly. Easy to get 150, 160. For physics, I'm telling. That's what. And we will cover all the topics in such a way that you'll reach that level at least. Okay, I'm not saying 180. 180 is the 2 years of preparation, but 150, 160 is still, if you revise it properly, you can get it. Okay, 120 is easy to get. And now coming to this question, now a student is trying to measure the diameter of a small steel ball, and least count is given. Okay, just whenever you are reading, always make a habit of writing whatever information you are getting. Okay, so that it will go into the mind. So MSR is given. Okay, MSR is given as 5 mm, and 0 of circular scale coincide with the 0 of the circular scale is coinciding with the 25 divisions of above the reference. So what is this? The circular scale reading is given as 25 divisions, and they are giving, if the screw gauge has an error is there, error is negative. So what you do finally, you have to, if error is negative, correction should be positive. If error is positive, correction should be negative. That's it. Okay, so we have negative, 0 error is there. Then they are asking what is the correct reading. So first you take the reading, then we'll make the correct. So reading is equal to what? MSR plus least count into circular scale reading. So MSR is 5 mm. We want answer in centimeters. Okay, let us write in centimeters. So 0.5 centimeters plus least count is 0.001 centimeter into 25. Okay, so this is thing, and it becomes what? 0.525 centimeters. Is this answer? No, this is just a reading. Now we have to make the correction. If you're making the correction, what is the correct reading is? What is the correct reading will be? You have to add plus the zero correction. What is zero correction? It is negative of zero error. So if you add that part, 0.525 centimeters plus 0.004 centimeters, so what will be coming out? 0.529 centimeters it will be coming out. Okay, so again, direct question. They will give the information, nothing innovative here. They will give some information, along with error will be given. If error is given, make sure you do the correction part. Okay, so this is, again, we are at the almost we are doing the instruments. Once it is done, we'll be closing it. And again, this is it, the units and measurement chapter, easy to score 8 marks sure. So today, in just 1 hour, you are getting 8 marks. Then next day we'll do loss of motion kinematics. Tomorrow, that is, we'll do both chapters together. Again, they are simple chapters. We'll do it together tomorrow also. Easy to expect two questions like this. 15 days, so 2 to 3 questions. So 40 to 45. Again, we'll be trying to at least 40 questions such way we'll do. Okay, so next, what is the question we're having here? So we have, again, screw gauge 1 mm, again least count. Okay, pitch we have pitch, fine. We have 100 divisions, number of divisions are given, so that what we can get out of this least count, they are expecting us to calculate. Okay, so what is the least count is coming? 1 by 100. 1 by 100 is 0.01 mm it is. Right, done. Then while measuring a diameter of a thick wire, it is the pitch scale reads 1 mm. That means the pitch scale is, pitch is generally for whom it is? Main scale. So main scale reading is given, that is 1 mm. And 63rd division is matching. So 63rd division is of what? Circular scale reading is given 63. Then they're asking diameter. That means they're asking for the reading. How to get the reading? Nothing innovative. MSR is 1 mm plus least count is 0.01 mm into 63. So what will be happen? So this is 1.63 mm, but we want answer in centimeters. It will be 0.163. It is. That's it. Okay. So very simple questions. And next, if we go for 1 year calibers, almost similar, but what is the thing is, it has a little bit lesser least count. And okay, how do you calculate here? Also, what is the thing you are seeing? You are seeing main scale. You are seeing another scale here, another scale here. What is this? 1 year scale. Okay, so 1 year scale is there, main scale is there. Then again, for any device, what is the first thing we are interested in? Finding least count. How to find least count? Again, direct questions have been asked on this. 1 MSD minus 1 VSD. That is, on main scale, these divisions are there, right? What is one division unit is? That value. And here also 1 year scale, you have the divisions, right? And you should take this. And they will not give this information directly. Okay, how the information will be given? They will give, okay, MSD will be given. Without confusion, they will give this, and they will say that, like, so 9 VSD are matching with 10 MSD. Then what do you do? How to get 1 VSD? 1 VSD is equal to like 10 by 9 MSD we should do. Okay, here one thing. Generally what will happen? This will be smaller, this will be bigger. They'll say 10 VSD is matching with 9 MSD, like this they'll become. Or else they will give 20 or 19, like this they will give the information. They are just examples. Okay, what is our objective is to find least count. How to find? 1 MSD unit we should take, 1 VSD we should take it, and you have to put it like this. Okay, so that's it. Once you know least count, then 50% is done. Next, how to take the reading. How to take the reading means, first you should know, you have to know MSR, main scale reading, and least count. Then we have to take 1 year scale reading. So again, you see the 1 year scale beginning. Before the 1 year scale, what are the thing you are seeing? The main scale value will be, that is a main scale reading. And then least count you already calculated. And how to find 1 year scale? That is where, so you have to be very, very careful, observative here. So You see these divisions, all of them don't match. Only one of them will match exactly. Like if this is matching exactly, you should count. Okay, this is 0, 1, 2, 3, fourth one. So fourth one is matching. You should take the 1 year scale reading as fourth one. That's it. So main scale reading is before the 0 of 1 year, whatever the reading is there, that is the main scale. Least count you calculate separately and you multiply with the one which is coinciding with the main scale. That's it. So here, this is how the questions is asked. You see, they have given n plus 1 divisions coincide with the main scale. That is what we are talking. What is the thing you are saying? N plus 1 VSD is equal to n MSD, and we are interested in VSD. What is 1 VSD is n by n plus 1 MSD. Okay, then we have got 1 year constant. Don't confuse. 1 year constant is also the least count only. Okay, so what is the 1 year constant, also known as least count, is equal to 1 MSD minus n by n plus 1 MSD. MSD, if you take it common, so 1 minus n by n plus 1, what will happen? It will be 1 by n plus 1. MSD, what is MSD is again 0.1 mm. That's it. So we want answer in terms of centimeters. Okay, we have mm. How to convert it into centimeters? So it is 1 by 100 into n plus 1 centimeters. It will be coming out. So this is it. So this is how we find the least count. Okay, so this is what we have covered. We have seen like most of the revision of the topic, units and measurements. So started with the basic unit conversion, dimension analysis, signal figures, rounding off, error analysis, screw gauge, 1 year calipers, done. Okay, so this is it. And but we are done for today for physics. Next we'll have chemistry. It will be started at 5:30. You can go through that. Definitely use a revision platform here that we are providing. And then tomorrow's class at the same time, 4 to 5, we'll be doing kinematics and yes, and laws of motion. So we'll do both the things. Okay, so we'll revise again very basic. What are the equations of uniform accelerated motion, non-uniform accelerated motion, circular motion? We'll be completing. Okay, I hope this has been very informative session for you. So thank you for your time. And basically what you have to do is revise these things. Revision will be giving